Alison Olcott Marshall. I'm Geology. Geology 121, which is a paleontology for non-majors class.
I am Kelsey Bitting. I'm a postdoctoral teaching fellow. This has been the course that we've been working on transforming this semester in the geology department. So we have transformed the class itself from a primarily lecture-oriented course to something that is much more interactive. The students are working in groups and teams throughout the semester. They are working on little activities throughout the class periods. And their textbook, as it were, for this course is The Sixth Extinction, which is a popular science book that looks at bringing together geologic history and ancient organisms and ancient extinctions and climate events with the modern sort of events that are going on today. We've known for at least 30 years in terms of education research, and particularly research on college science courses, that lecture just is not an effective way to engage students in science. And in particular, students who don't have a lot of background, especially at the 100 level, really just don't necessarily have enough context or enough experience with science and with the topics that we're talking about to get very much out of a lecture. It's all just sort of a fire hose approach. And so they get hit with a lot of ideas, but they don't know how to make sense of them. And so there's a growing body of literature that shows that there are all kinds of things that we can do that are a lot more effective in terms of teaching science content, in terms of getting students excited about science, and in terms of just getting, developing critical thinkers.
I started the class in thirds. So the first third was geology basics. Here's how a fossil is made. Here's how we read fossils. Here's types of fossils we have. The second third, we focused on the Cretaceous, so when dinosaurs were flourishing. So we could look at ecosystems, reading food webs, and extinctions. Of course, when the dinosaurs go away is a good extinction to look at. And then the last third is sort of project, and then also modern impact. They do all sorts of activities. They do stuff in Google Earth. They do stuff with paleontology databases where I have them interpret and assess paleontology data. One time I made them decide they wanted to be a fossil when they died, and I made them write their last will and testament for how their family had to deal with them, so I get a fossil record. So sort of all sorts of different ways to approach this.
Throughout the semester, we've had students assigned to teams to leverage the idea of the social aspect of learning and to try to get students collaborating. We know that students themselves, when one person understands it, it's much more likely that they're going to be able to explain it to their team members because they're coming from a similar perspective to their team members, whereas we've had a little more experience with all this and we may not even be able to see the forest for the trees. So we've just really tried to leverage as much as we could in terms of getting the students engaged themselves.
Giving them a traditional final exam didn't seem like it would let them reflect on what they had learned. And so instead of their final, we've had them do this final project where we've scaffolded them through it over about the last month and a half. The end product is they have to look at an extinct organism and a modern threatened relative. So something that's related to the extinct organism that it's being threatened right now with extinction. So for both animals, they have to look at the habitat, the environment, the geography, the food source, how they fit in the food web, and then come up with a mitigation plan for the modern organism for how to prevent them maybe from going extinct. And then they had to present it in any form except PowerPoint. The first couple of weeks were hard because they were like, "Lady, you're crazy." And now they're like, "Oh, this makes sense. And I see why you're doing this, and I see why I had to work."
So the first week or two of class, they were a little iffy and they gave us some really funny looks and the students were not quite sure what to do with this. And over the semester, really we just saw a transformation. They started to get excited about what they were doing and they started to see that they had the ability to do science themselves. And I think that really changed their perspective on the whole thing and they started to recognize the value of this approach. At the end of the semester, we had the students write a letter to future students to talk about what it was that they wish they had known when they started and what strategies were effective for them. And an awful lot of the students said, you really do have to work in this class, you have to think, you have to show up, but all that said, it's really worth it and you're going to learn so much, so just stick it out. We now have 60 students who didn't care or may not have cared at all about science when they came in the room, who are now excited and interested in learning more about what they've learned so far. And so I think we've created self-perpetuating learners who are going to go out and find more information themselves.
I've learned that this is a wonderful way to teach. The students enjoy it, I enjoy it. I think we've all learned. I've learned from them because they're bringing so many different disciplines in. So many points of view. So I've learned from them. And they're involved in science and in paleontology and in geology in a way I've never seen any other class. The fourth or fifth time I've done this. It's been a really great experiment.